Hi, I'm Nikki from EducatedNow.com. Today we're going to take a look at place value using the base 10 blocks. Although this is review for most middle school age students, it is a good idea to make sure that they really understand the concept of place value and the patterns found within. So we will have two goals for this lesson. The first is for students to see the relationships between place values, both in decimal and whole numbers, as well as for students to understand large and small numbers concretely using the base 10 blocks. For the accessing prior knowledge part of this lesson sequence, we're actually going to be using the base 10 blocks, but I wanted to start off here by showing a traditional place value chart that most students have been taught place value with since elementary school. Using a chart is very useful. However, it is still working in the abstract, in the symbolic part of math, rather than in the concrete that the blocks provide. And what I've found is students, even in the middle school grades, do not realize the patterns within place value and don't have a clear concept of what the patterns are in the place value, as well as the difference between ones, tens, hundreds, thousands, and especially tenths, hundreds, thousandths, etc. when we work into the decimals. With the base 10 blocks, they can easily see the connection between the different place values. So let's take a look at place value using the base 10 blocks. Because we can use base 10 blocks for both whole numbers and decimals, we need to let students know what 1 is equal to. So in this case, we're going to start with the smallest size block as equal to 1. From there, ask your students to name and give reasons why for each of the other size blocks. They can also draw pictures of each size blocks and write their value in their notes. What we're looking for here is for students to realize that once they have 10 of each of the different size blocks, it is equal to the next sized block. So here we can see that 10 of the 1 blocks is equal to the next size block, which we would call a 10 in this case, because we've labeled this as 1. Next, students can see that 10 of the 10 blocks equals 1 of the 100 blocks, so they would label this one as 100 because it has 100 ones in it, or 10 groups of 10. The largest cube is often mislabeled by students. They often call it 600 because they are counting the 600 squares that would make up the surface area of the block. So it is important here that you ask them to imagine that this block is filled in and how many of these individual smaller cubes, the ones that we started with, would it take to fill this entire cube. And of course we can stack beside it and see that it would take 10 of our 100 blocks, so therefore 1,000 to fill the entire largest cube. After we have explored the base 10 blocks and named each of them, we can come back to our traditional chart and take a look at the patterns that we see. Hopefully students will have discovered that it takes 10 ones to make a 10, 10 tens to make 100, and 10 hundreds to make 1,000. So the pattern is that once we have 10 of each type, it actually jumps to the next place value. I would then ask my students to predict what they think will happen when we look at the decimals. After they've had a chance to make their prediction, share out the predictions using partner talk, and then we can move forward into the processing part of this lesson sequence. For the processing part of this lesson sequence, we're going to start with the largest cube as actually equaling 1 whole. So you'll have to ask your students to forget what we had just done, and we're now going to change the value of a whole because we're going to be exploring the decimal part of the place value chart and look to see what kind of patterns we can find there. So if this equals 1 whole, in partners, ask your students to name each of the other size blocks and give reasons for why they named them the way they did. So what we're looking for here is we want students to see that this block is 1/10 of the whole. So therefore, it would be called a tenth because it is one piece out of 10 of the whole. Our past mistakes in talking about decimals have been that we've called this 0.1. 0.1 gives no indication to the actual size of the number, and it also makes it far more difficult for students to change between decimals and fractions than if we called it 1/10. So we need to change our language and insist that our students call decimals by their proper name. This is called 1/10. The stick would now be called 1/100th because it takes 100 of them to make up our whole. And our smallest sized cube would be called 1,000th because it takes 1,000 of them to make up our whole. It is also interesting for students to take a look at the relationship between these size blocks as they compare to whole numbers. For instance, you could ask them, how many thousandths are there in 100th? The answer, of course, being 10. How many hundredths are there in a 10th? Again, the answer is 10. And finally, how many tenths are there in a whole? Returning now to our place value chart, we can take a look at the pattern. We noticed earlier that every time we had 10 of the certain size block, it was equal to the next size place value block. We can now see that that pattern does continue when we work into the decimals. We knew that there were 10 tenths in one whole, 10 hundredths in a tenth, and 10 thousandths in a hundredth. This also gives students the chance to see the difference between the sizes of numbers, especially with the decimals. We really want students to understand that a tenth is significantly larger than a thousandth, and it's also quite a bit bigger than a hundredth. That will help them when they start to order decimals and to check for reasonableness in their answers when they're working with decimals. After you've gone through several more examples like the ones we've just covered, I would ask my students to use partner talk and discuss what they understand about the place value system and any of the patterns or relationships that they discovered today. After they've had a chance to share with their partners and then share aloud to the whole class, I would ask them to do a small piece of writing in which they explained the patterns that they found and their understandings of the place value system. You can also use your place value chart, but use more open questions like the type Marion Small uses. I was at a workshop with her recently, and she gave a similar type of question to this. Using a place value chart and 6 counters, make a number that is greater than 800. Here would be one example that a student can give using 6 counters and a number that is greater than 800. You could then ask some extension questions such as, if you were going to change in one of your counters in the column to the right without changing the value of the number, how many counters would you need? So if we need to change in one of these counters for counters in this column, how many more counters would we need in order to still keep 2,400 as our total? So if I took this one from here and added it to here, I've obviously changed my value significantly. As you can see, I would need to add 9 more counters if I was to replace my 1,000 with hundreds and keep the same value. Here I have 1,000, but I also have another 1,000 and my other 400, so I still have 2,400. This is an activity that again reinforces the idea that once we have 10 of any sized block or counter, it jumps to the next place value. Following this, I want to give my students a chance to explore very large and very small numbers. This lesson really only covered from thousands down to thousandths. So if we want them to explore numbers above 1,000,000 and less than 10 thousandths, we need to do a little bit more work. One option would be for students to go to the computer lab and research where very large and very small numbers are found, and maybe what occupations use them, aside from math teachers. Another idea would be to take your students outside. If you looked at your field of your school and you counted each blade of grass, how many would you have in your whole field? Obviously now we're getting into very large numbers. You could even reverse that and look at the entire field as one whole and then ask students what would one blade of grass be represented as. It would obviously be a very small decimal. There's many things in nature that we could use when we're looking at very large and very small numbers. For the reflection part of this lesson sequence, I would ask my students what they think is the most important thing about the place value system and why. I would also ask them how using the base 10 blocks affected their understanding of the place value system. Thank you for joining us at educatingnow.com while we explored place value using the base 10 blocks.